So this specific question is about the substitution that we have been given for. So the substitution is in place of x, you got to take 4 sine square theta, and you have to show that the given indefinite integral reduces to arc sine root x upon 2 plus b times b root 4x minus x squared plus c. Now the general mistakes that we do is, first thing is that figuring out the substitution. Now here, since the substitution is already given, that problem gets solved. Now the second problem that actually arises is with the process itself, the substitution process itself. Okay, now lots of students, what do they do is their substitution is just about putting the integral. So x is 4 sine square theta over 4 minus 4 sine square theta times d. Instead of dx, they just directly put d theta, which is absolutely incorrect. So this is wrong. This is wrong step. You can't do this. So the important thing is that there is something interesting here, that if you don't do it, your entire integral is going to be wrong. So what you do is, your number one is, the moment you make the substitution, whichever variable you're integrating with respect to. Now, since my variable has changed from x to theta, I need to integrate and find out the derivative in terms of, let's say, if I have, let's say, dx will be, so dx by d theta. First you find that it is gonna be 4 times sine theta the whole square, if it is here. So this is my function. If I do the derivative, 2 minus 1 into, so I applied the power rule first, into the derivative of sine theta, which is cos theta. So what we get is basically 8 sine theta times cos theta. So that's the derivative of the dx by d theta. And so if we get, in place of dx, I can put 8 sine theta cos theta times d theta. Now, the silliest of the mistakes that we get to see is that students don't know the derivative part. You don't understand the derivative of 4 sine square theta, you can't do this integration. So the chain rule, the integration substitution method becomes very important out here. If you don't know how to integrate with the substitution, you will just directly, let's say if you replace, instead of dx, if you replace d theta, your entire step marks is gone, and you hardly will get any marks for this then. So here, in place of dx, now you can see I can put 8 sine theta cos theta d theta. So I'll put 8 sine theta cos theta and d theta. So now after this, what you get is, if you integrate this, if you simplify the inside root, you take 4 common, so 4 sine square theta over 4 in bracket 1 minus sine square theta times 8 sine theta cos theta and d theta. So now you're going to just cancel this out. So sine square theta upon this will become sine theta upon cos theta. If you see, it is sine square theta upon cos square theta, because 1 minus sine square is cos square theta. So again, use of identities also play a very important role in understanding such question. So sine theta upon cos theta, if you integrate, this is gonna be, so 8 times sine theta cos theta. This is already integral sine I have put here. Now d theta. So what we get is, our step that we get is 8 sine square theta. So 8 sine square theta is our next step. And now we have to integrate 8 sine square theta, which is again a hurdle, because lots of times students just write down 8 sine cube theta upon 3. It's like considering this is like a power rule. So remember that wherever you get an integral of sine square or cos square as a higher level student, remember to use the identities, the trig identities. So sine square theta can be replaced by 1 minus cos 2 theta upon 2. And how do we get this? How do we get this is by making sine square theta the subject. So cos 2 theta is 1 minus 2 sine square theta. So if you make sine square theta the subject, you're going to get this part. So what I'm doing is now I'm going to put this value out here. So 8 is outside. I'm going to put 1 minus cos 2 theta upon 2 d theta. You could cancel out this 8 with 4 here. So you get is 4 1 minus cos 2 theta. So one integral, if you do it, is theta itself, and minus cos 2 theta integral is sine 2 theta upon 2 plus c. Now you open up the bracket, what you get is 4 theta minus 2 sine 2 theta. Our next step is to actually see how to replace back the things. So I would make from here, I would make theta the subject. So sine theta is going to be plus or minus root x over 4, which is plus or minus root x over 2. So since it has been specified that the let's say if the angle is in first quadrant or something like that, you have to choose out just the positive value. So I take only the, let sine theta be root x by 2, and hence what I'm going to get is theta. So sine theta, so sine theta is root x over 2. So theta is going to be arc sine root x over 2. So that comes out here. So that comes out here at this part here in place of theta. And now the hurdle is to substitute for sine 2 theta. So sine 2 theta, if you look at, so sine theta we got is root x upon 2. First, what we're going to do is write down the value of sine 2 theta. How do I find out sine 2 theta? Using double angle once again. So sine 2 theta is 2 sine theta times cos theta. So what we do is you have, let's say, sine theta as, let's say this is a triangle here. Assume this is theta. If this is theta here, this point is opposite is root x, hypotenuse is 2. So you can find out this value, which is going to be root of, by Pythagoras, this value is root of 4 minus x. Now cos theta will be root of 4 minus x over 2, because it's adjacent over hypotenuse. Now we come back. So when you come back and substitute here the values, so the final answer that you get will be 4 sine inverse or arc sine root x upon 2 minus 2 sine theta cos theta. So minus 2 sine theta is nothing but root x upon 2, and cos theta is basically root of 4 minus x upon 2. So the important thing here is root of 4 minus x upon 2 is cos theta. So now if you just simplify this 2 and 2 get cancelled, and if you take inside the root, what we get is, my final answer is going to be 4 sine inverse root x upon 2 minus root of 4x minus x square over 2 plus c. So the value of a that we get is 4. Value of a here, actually there's a arc sine, so value of a is 4, and value of b that you get is half, negative half. So that's how you do this particular question.